Okay.
All right. Hello, everybody, and welcome. I am here today talking with Dr. Kevin Henke about the Castile Formation. Dr. Henke is a former conservative Christian and young earth creationist. He is now an agnostic and has been studying young earth creationism as well as its claims for well over 40 years. You've probably seen some of his work online. He received a Ph.D. in geology from the University of North Dakota in December 1997, and he's currently retired, which means we get his time today. We're going to be discussing the geology of the Castile Formation of West Texas and how and why it's incompatible with young earth creationism and flood geology. Now, the way that this is going to work is we are going to listen to Dr. Henke give his amazing discussion and a lecture. And at the end of that, which is going to be about 45 minutes to an hour, probably more on the hour end, we're going to have a Q&A. Now, I'm really excited for the Q&A because this is a great opportunity for me to fill in my geology holes, but it's going to have to be restricted to the Castile Formation because that's what Dr. Henke is here to talk about. So I've got the mods raring and ready in the chat to dunk on people who are trying to keep this off topic. So, you know, we got our eyes on you. So with that, we're going to go ahead and start. So Dr. Henke, if you would like to say anything and pull your screen up, by all means.
Well, thank you very much, Erica, for inviting me on. And I'm glad to be here, and I look forward to some interesting questions. If people have questions about other topics beside the Castile Formation, they're certainly free to email me, and I'll try to answer them that way. But I did want to kind of stay on topic with the Castile Formation tonight. So I'll start my presentation here, and let's see if we can get this going.
The dreaded screen share.
Okay, let's see. All right. Yeah.
Just a bunch of clicking through.
Okay, can you see it?
Not yet. You might have to click the box and then click share screen.
Okay, just
I think that's the trickiest part of it, unfortunately.
Yeah, I'm getting echo too.
Oh, I'm not getting any echo on my end.
Yeah.
Do you see the section where it says choose what to share?
All right. Okay, now I see it says share.
Okay, just click share, and when you do, it should pop up. Okay, I see you. Perfect. All right, you should be good.
All right. All right, now you see this?
Good to go.
Okay, you do see my presentation, right?
Yes, I can, and everyone else can as well.
Okay, I'm getting some bad feedback here.
I'll mute myself so that you don't hear anything.
Okay. Okay. Now, let's see. I'm hopefully that now. Can you hear me?
Yes. Sorry, I gave you the thumbs up so it wouldn't echo. But yes, I can hear you.
Okay. Now it's still echoing for me, so something's very wrong.
Let me see here.
All right.
How is that on the echoing? Any better?
Let me see if this works. No, it's still it's still echoing.
Still echoing. Okay. How about I'll mute myself real fast and then you talk and see if there's any echo.
Okay. Okay. Testing 1, 2, 3. No, it's echoing with about a 5-second delay.
Let me see if anybody else can hear any. Chat, will you let me know if you can hear any echoing on your end? Okay, now they weren't having it, but now they are. So let me see what I can do here. Because we weren't having any echoing earlier. Do you by chance have this on in the background at all?
That I just don't know.
Okay. All right. How is it now for everyone who can hear it?
Okay, let me try this. Testing 1, 2, 3. No, no, it's echoing.
That's so strange because I'm not getting any echo on my end. Chat, are you guys getting any echoing? Let me see. Switch back to this. Do you have YouTube up by chance?
Let me check. Let me see. I might very well.
Because chat is telling me they've got no echo. And I'm not getting any here either. So I think it might be on your end.
No, I don't have.
Is it maybe the headphones? Could you?
No, I don't have YouTube up. YouTube up. No.
Okay, I'm trying to think what it could actually be then, because I've got no echo here, and the chat isn't hearing any echo at all. And do you hear yourself echo when you're speaking? Is that the issue?
Yes. Let me close my. Yes.
Okay, let me think here. Well, someone in the chat saying it might. Okay, go ahead. Sorry.
Okay, I just closed some screens and I just closed some screens and it's still echoing. It's still echoing.
Let me see what's going on here. Because I'm thinking it's got to be something to do with your headphones, because I'm not getting it on the receiving end and neither is the chat. Do you have speakers on your computer? Do you hear it without the headphones?
No, wait a minute. No, I cannot. I have to have headphones.
Okay.
Let me check to see if I've got some old-fashioned. No. Yeah, I have to have headphones. I don't have speakers.
So maybe try leaving StreamYards and resetting your computer and coming right back. Would that work? You want to get back?
Well, we'll try.
I'll still be hosting here. Okay. All right. Okay. Well, thanks everybody for being here. We're going to try to sort it out. I'm taking Mr. Wilford's advice and we're working through it. I'm not 100% sure what's going on Kevin's end. I'm a little worried it might be StreamYards or headphones related. But in the meantime, how is everyone doing? Is everyone doing well on the old webosphere? Is that what we're calling it these days? Things are doing quite well for me. While we're waiting, I hope some of you saw the community post that I put out there. Dr. Dan Stern-Carnell and I have had the utmost pleasure of getting some attention from Creation Ministries International in an official post that is nice and very passive aggressive. So we'll be doing a response to that at some point. But other than that, things have been going pretty chill. I've got a very big video for you guys that is to come out very soon-ish about my trip to the Creation Museum and the Ark Encounter, which is, boy, it's something else. Yeah, CMI did say I should be more humble or gay. Okay, we got Kevin back. Let's see if we can't hear him.
Okay.
How's it now?
Yeah, can you hear me?
Yes, I can.
Okay. I don't get any echoing. So that's good.
That's great.
Yeah. Now let's see if when I bring up my PowerPoint slides, if that's going to create any problems here.
Fingers crossed.
We tried to, we did do testing beforehand, but it just didn't help.
I know.
You never know with some of this stuff, and I'm new at this.
I'm telling you, Kevin, it's always something. Whenever you do stuff live, something always happens. We could have done 10 tech preparations and something probably still would have happened. Yeah. But I'm glad that it's gone right now.
Yeah, let's see if my PowerPoint slide comes up fast here. Okay, yeah. All right, now let me see if I can get this.
Okay, that's me sharing.
All right, I'm going to share screen and press the blue share button.
Yes.
And then this one,
Check.
check.
I see it. Yes. Okay, I'm putting it in
Okay.
right now.
All right, now I'll bring this up. Now, can you see this?
Yes.
Okay, and there's apparently no echoing. I'm not getting any echoing right now, so that's a good thing. And I'll try to start here. Sorry for all of this mistakes here.
No, absolutely no problem. I don't think it's anything you're doing.
Okay.
I think it's tech being tech.
Okay. Okay. So anyway, I'm going to talk about the salt deposits, or actually evaporites, of the Castile Formation and the fatal problems for young Earth creationism and flood geology. And this is my website, and you can go there and you can get my email address if you want to contact me. And a lot of what I'll be talking about this evening is from an essay that I wrote on the Castile Formation that's on my website. So you can go there for additional details or references. Now, I should point out that if you decide to email me about the content of my website or any statements that I have made tonight, I do have the right to post your emails on my website along with my comments and any rebuttals. Now, let's get some background information. Geologists use something called modern uniformitarianism. It's also called actualism and naturalism. And modern uniformitarianism is essentially the same procedures as the naturalism used by chemists and biologists and other scientists. Modern uniformitarianism refers to both the methodology used by 21st century geologists to decipher the geologic record and the natural processes that produce that record. Now, decades ago, geologists abandoned Lyell uniformitarianism, and this was the uniformitarianism that developed in the 19th century and then was used for the first part of the 20th century. And a lot of young Earth creationists still like to attack the Lyell uniformitarianism as if geologists still use it. But Lyell uniformitarianism states that the natural processes affecting the geologic record today are the same processes that affected the record in the past, and that the overall natural rates of erosion, deposition, volcanic eruptions, and so forth are constant over time. Now, today, geologists recognize that natural rates and conditions are not constant. For example, erosion was probably higher before the evolution of land plants in the Silurian. And then if you had, let's say, a 50 centimeter thick Ordovician sandstone, that could represent hundreds of thousands of years of net accumulation, or it may have been dumped literally overnight by an ancient hurricane. You'd have to look at the sandstone in more detail to see if you could figure out the depositional rate, and a lot of times it may not even be possible. Also, glaciers dominated the landscapes sometimes in the past, but were absent during the Eocene and other times. Volcanic eruptions and meteorite impacts were more common 4 to 4.5 billion years ago. Now, during parts of the Paleozoic era, large restricted marine basins and dry climates allowed for the production of thick salt or evaporite deposits. Now, today, these deposits are not forming to any large extent because of the lack of large, effectively restricted marine basins in dry climates. Okay, so modern uniformitarianism simply states that the laws of chemistry and physics are constant over time and space. In other words, the speed of light hasn't changed, E equals mc squared, and so forth. The geologic processes and conditions are no longer viewed as necessarily constant over time. So modern uniformitarianism allows for local, regional, or even global catastrophes over time, such as the Chicxulub impact that probably killed off the dinosaurs 66 million years ago. That was an earth-shaking event, literally. But there were also slow and gradual processes developed in the geologic record, such as Varves and salt deposits. So the old saying that the present is the key to the past is now only viewed as a general rule, with many exceptions. Okay, so certainly modern geologists like to look for modern analogies of depositional environments for environments that occurred in the past, but they're not required to decipher how rocks formed in the distant past. We can use laboratory fieldwork, computer models, and rational reasoning based on the laws of chemistry and physics to successfully understand ancient depositional environments that no longer exist on Earth. For example, banded iron formations are no longer forming on Earth, but we figured out through laboratory fieldwork and computer models pretty well how they formed 1.8 billion years ago and earlier. Okay, here's a few definitions. A lamina is a sedimentary layer or sediment rock bed that is less than 1 centimeter thick. And we see here some photographs of the Castile Formation with the laminae, and they're pretty thin. A rhythmite is a group of laminae whose compositions are obviously part of a repetitive cycle. You can see this here in the Castile Formation. You've got a brown layer, white layer, brown, white, so forth. And they're due to seasonal variations like with Varves, tides, frequent storms, or other cyclic processes. Varves are rhythmites, but not all rhythmites are Varves. Okay, so a Varve consists of 2 or more sediment layers with distinct compositions that were all deposited within 1 year by definition, and usually they're laminae. Technically, Varves in sedimentary rocks should be called varvites, but in most cases we just refer to all of them as Varves. Modern Varves are not only form in temperate freshwater lakes like in Minnesota, Scandinavia, and Canada, but they also form in seas like the Black Sea and arid environments like the Dead Sea. Okay, I'm going to try to open up this link here, and I hope that it will come up. It may not. I have to back out temporarily here, see if I can get it. But this illustrates 2 different rhythmites from a couple of Swiss lakes, and it's taken from Lambert and Hachou, 1979, and the late Glenn Morton put this or posted this on his website, and it illustrates very well the difference between Varves and just ordinary rhythmites. And I don't think it's going to come up. Oh, yes, it is. Okay, just a second here. Let's see if we can get this up.
No worries. You're sharing the whole screen, so the second it pops up, we'll be able to see it too on your screen.
All right. Do you see the Varves yet?
Not yet.
All right. I'm going to move it over here.
We see them.
Okay. All right. Great. Okay. Over here on the right are Varves from Lake Zurich. And in the winter, when the lake is frozen over, well, then organic matter from the previous growing season accumulates as this dark, organic, rich layer. Then when the lake thaws in the spring, you get sediment washing into the lake and some sediment blowing into the lake, and it forms this lighter colored layer of clay and silt. So this is called the couplet. It forms a year's deposition, 1 year's deposition with a dark layer and a light layer. Now over here are some rhythmites. These are storm layers in Lake Wallensee. These are not Varves. And you can see that they're somewhat regular, you know, some lighter areas and darker areas, but you can see the difference here. So anyway, let's see. We'll continue here. All right. Can you see my presentation again?
Sure can.
Okay, let's go on. So we can talk about the composition of Varves. The composition of Varves will greatly vary with climate, the erosion of local rocks and sediments, whether a body of water is fresh, brackish, or marine, and the size of the depositional basin. So not all Varves are the same. Now, back in 1997, young Earth creationist Michael Ord wrote a very error-filled book where he claimed that pre-Pleistocene glacial deposits were actually deposited as submarine landslides during Noah's flood. We have identified glacial deposits in the Precambrian, the Ordovician, and the late Paleozoic. So Michael Ord is a retired meteorologist, and I think he's probably a very nice guy, but he's not a geologist. He does not understand geology, and he does not understand modern uniformitarianism. So I wrote a critique of this book at No Answers in Genesis in 1999. And understandably, he got rather upset with this presentation or this web essay. And so he wrote a couple of chapters in a book with Ord and Dr. John Reed in 2009, replying to my 1999 essay. And I'm going to talk about the second chapter here, Do Varves Contradict Biblical History? Because he brings up the Castile Formation in this chapter. And so I responded to this book, including his comments on the Castile Formation. So I'm going to go through that today. And I'm also going to take a lot of information out of a book by Eric M. Reinfort. It's at Amazon.com. It's an ebook, and it's a very even-handed review of young Earth creationist and naturalist or uniformitarian views of salt deposits. And I have his permission to use his figures and other information out of this book. Okay. So we'll start here a little bit late. The Castile Formation is located in the Delaware Basin of West Texas and Southeast New Mexico. And thanks to over 100 years of petroleum exploration, the Castile Formation is very well known from outcrops and numerous well core samples and geophysical studies. So this is a very well-known formation. We look at the geology of the Delaware Basin of West Texas. The sedimentary rocks are 7.3 kilometers thick. And here's a little bit of the Castile Formation. It represents about 550 meters on average of that 7.3 kilometers. Now, young Earth creationists believe that Noah's flood occurred in about a year. And Ord and Reed, using passages out of Genesis, date the length of the flood at 370 days. So all of these rocks from here up to here were supposedly deposited during Noah's flood. There is alluvium on top of the sedimentary rocks. Young Earth creationists would consider that to be post-flood. So here's a cross-section of the Castile Formation. We have a basin here, and again, the formation averages about 550 meters thick. I'll have to get some water here occasionally. Yeah, the Castile Formation formed in the late Permian period about 255 million years ago on what was then the west coast of Pangaea. And the latitude was about 5 to 10 degrees north, and it was a very dry climate, similar to modern eastern Kenya in East Africa. So this is what the geology looks like. You had the Delaware Basin, a depression. It was surrounded by these reef rubble carbonates, and that cut it off from the open ocean. And then you also have some red beds further away from the basin. Red beds are iron-bearing sandstones and shales. And so there might have been some channels in the reef rubble, possibly a surface channel called the Diablo Channel over on the west side, and maybe the Hovey Channel on the south side. But these channels aren't really necessary. The seawater would come in through the subsurface, through the reef rubble, and recharge the brine as it was evaporating. And that's how the salt deposits formed. Now, Anderson, in 2011, argues that there was 209,000 years of continuous sediment deposition. And that's very possible. This area had low tectonic activity, and at that time, the sea level was pretty stable. It was very, very hot, dry summers. The winds would come out of the northwest in the summer, and then during the cooler or more humid winter, the winds would come in from the west. So here's a photograph of the Castile Formation. You have white gypsum layers and then organic stained calcite. And the Castile Formation consists of organic material, calcite, and hydrate/gypsum and then occasionally halite layers. And so here's the composition with the mineralogy and other components. You had algae and other phytoplankton growth in an isolated marine basin, and this caused calcite to precipitate. And the organic matter occurred, as in some cases, as distinct layers, but also mixed with the calcite as it was precipitating. And so calcite is calcium carbonate. Also, as the season got warmer, calcite would begin to precipitate as the seawater evaporated. And then as the brine really started to evaporate, you would get gypsum precipitation. And the gypsum could convert into anhydrite, just plain calcium sulfate, by either being buried, or else if you had a bottom brine at the bottom of this Castile Sea, and if it was rich in sodium chloride and at temperatures above 18 degrees Celsius, then the gypsum could convert to anhydrite on the bottom of the sea. So as the salt concentration increased in the brine, the remaining brine becomes more difficult to evaporate. So the evaporation rate of the brine changes over time. It starts out quite quickly with the fresh seawater, and then as the brine concentrates, it slows down. The sodium chloride is only present in about 1.5% of the Castile Formation. In most years, the humid and cool season would arrive before the halite could precipitate. And then with less evaporation from the cool and humid season, the brine could then be diluted with seawater or expelled near the bottom of the basin. And I'll show this in some illustrations here in a little while. Now, if you really take seawater and really evaporate it, you start getting magnesium and potassium sulfates and chlorides. And these are not seen in the Castile Formation, which means that the brine never got close to completely evaporating. Now, what's a really fascinating property about the Castile Formation is that you have all these little layers, of course, about 209,000 of them. Many of them are less than a millimeter thick, but they can be traced over distances of 113 kilometers. Is this incredible? And this forms from a very, very homogeneous brine. So the brine would become saturated with calcite and would precipitate a little organic rich layer of calcium carbonate over 113 kilometers. And then as it evaporated more, it would get saturated with gypsum, and then it would evaporate an overlying layer of gypsum over 113 kilometers apart. So this is just really amazing, fascinating to me. Now, Kirkland et al. Comments on the lateral extent of these layers. He says most laminae can probably be correlated unequivocally throughout almost the entire basin to within a fraction of a millimeter. Also, the strontium chemistry can be used to correlate the laminae over distance. So what happens is, for example, this layer would have, it's an organic calcite layer, would have a certain strontium concentration, and then the layer above it would have a different strontium concentration, and the layer above that a different strontium concentration, but the strontium concentrations would be consistent across the 113 kilometers. So we're able to distinguish the various layers from each other over 113 kilometers. Now, young Earth creationists read and or have no problems with tracing these correlations over 114 kilometers. However, they complain that we don't see this type of environment today. And they're invoking outdated Lyell uniformitarianism. Again, under modern uniformitarianism or actualism, modern analogs are not required for every depositional environment seen in the geologic record. So we don't have to have a modern environment producing salt varves over a distance of 113 kilometers. However, we do have varves in the Black Sea, silicate minerals, that extend over 200 kilometers. So certainly varves can form over vast distances, and these claims by Reed and Ord 2012 are inaccurate. So anyway, what Mr. Ord tries to do is to explain how the Castile Formation could form from a brine during Noah's flood. And he's thinking about a low temperature sedimentary type brine. And first of all, he denies that conditions were always turbulent during the flood. He said that there were deep and quiet basins that could form supersaturated brines. But how would this work? Now, naturalists would accuse Ord of invoking ad hoc calm areas during an imaginary flood, rather than recognizing that catastrophes, including natural ones, cannot explain everything in the geologic record. As concluded by modern uniformitarianism, the geologic record is a product of both natural catastrophes and slow processes. So here we're going to do some math that Ord didn't bother to do. First of all, we'll go back to the sedimentary record in the Delaware Basin. And again, Reed and Ord are saying that all these rocks from here down to here were deposited in 370 days. Now, where's the amount of time in only 370 days for the depositional environments to periodically calm down, produce the Castile laminae, and then still produce the rest of the 7.3 kilometer thick pile of diverse sedimentary rocks? Plus, there's a lack of time for tektonism. You have to fold the rocks up to form the Delaware Basin and the Permian basins, other basins of the area. And also you have to eliminate the heat from the catastrophic plate tectonics that most young Earth creationists believe in. So we're going to do some calculations here. Let's assume that all 7.5 kilometers of this sediment, excluding the Castile Formation, formed in 5 days during the flood, somehow. Okay, this gives a maximum amount of time for the Castile salt layers to precipitate. And we should note there were probably salt deposits in the other formations, but we're going to ignore them for the benefit of young Earth creationism in this calculation. So we're dealing with 209,000 calcite layers and 209,000 gypsum and hydrite layers. We're going to ignore the halite and organic layers in the calculation. Okay, this leaves 365 days for 418,000 chemically distinct calcite and gypsum and hydrite layers to form. Plus, each layer has to uniformly cover distances of up to 113 kilometers. So there's 525,600 minutes in 365 days. And so that leaves 525,600 minutes for 418,000 layers to form. That means each individual calcite or gypsum layer has to form in about 1 minute and 15 seconds. Somehow, each saturated solution of calcite or gypsum must cover and precipitate a uniform but thin layer over 113 kilometers in 75 seconds. And how that would come into existence, I don't know. Oof. So here we go. We're going to do a calculation. Now, let's imagine that somehow we get 418,000 brines or whatever forming in the middle of the Castile Basin. And they can spread out evenly at 56.5 kilometers, so the total distance here is 113 kilometers. They would have to spread out at 2,696 kilometers per hour or 1,675 miles per hour to cover 113 kilometers, with each single layer every 1.25 minutes. And they'd have to do it 209,000 times at least. So this isn't realistic at all. But this is what happens when creationists propose a model and you look at it in any detail, it falls apart. So again, how could all these layers form? How could a stable brine exist during a chaotic flood? How could water-soluble layers, especially the halite, survive during a chaotic flood? And again, I would like Mr. Ord and other young Earth creationists to tell us what were the specific pH, temperature, and other chemical changes that would allow all of these layers to rapidly form during the flood. And where's the evidence for this? So Mr. Ord arm waves and falsely argues that only the scale of the flood was capable of producing these thin layers that extend over distances of tens of kilometers in deep and wide basins, such as the Castile Formation. And in reality, young Earth creationists need a magic wand to produce the Castile Formation from a brine. It just doesn't work. And so what a number of young Earth creationists do, including Ord, is invoke what is Dr. Guy Bertholdt's laboratory studies. And Ord uses Dr. Guy's Bertholdt's laboratory studies to explain the laminae in the Green River and the Castile Formation. Now, Dr. Berthold conducted a number of laboratory studies that demonstrated that laminae can quickly form from silicate sand and other clastic sediments flowing in air and water. The process sorts hard silicate grains by size, shape, and density, but this doesn't apply to chemical precipitates. And so Mr. Ord inaccurately accuses me of not appreciating laboratory results from Dr. Berthold and others. I certainly recognize that laboratory studies from Dr. Berthold and others are very relevant to field geology, very useful. But the laboratory studies have to be properly applied to the field results, and this is something that Mr. Ord is not doing. Dr. Berthold's work applies to laminar or layered deposits in boom sequences from deep sea landslides, not salt deposits. And so Mr. Ord is misusing this work. So you get underwater landslides in the deep ocean off the continental shelves, and they produce these what they call boom sequences. You have ripples, and you have some very mysterious thin layered flat lamina in these deposits. And Dr. Berthold's work can explain those lamina in these boom sequences. But Dr. Berthold's work is no cure-all to explain away Varves and all other laminae that are fatal to flood geology. Dr. Berthold's work, again, involves physical processes and not chemical processes. Now, what's interesting is that Dr. John Whitmore, who is a young Earth creationist, has criticized Mr. Ord for using Dr. Berthold's sorting mechanism to explain the origin of the Varves in the Green River Formation of Wyoming. And so here's what Dr. Whitmore says. Yet Ord, this was back in 2006, yet Ord and others who proposed mass flow sedimentation for the Green River Formation have failed to support their hypotheses with even a single example of a graded bed or how finely laminated sediments could have been made by mass flow. Citing Berthold's work seems inappropriate because his experiments dealt with heterogeneous particles to produce laminae. The Green River laminae are not thinly graded beds, as Berthold produced. They are composed of micrite, which is fine-grained limestone, and kerogen, which is organic material. I am not aware of any experiments that have rapidly produced laminae with the materials similar to those in the Green River Formation. And Dr. Whitmore's very wise criticism also applies to the Castile Formation. Now, how did Mr. Ord respond to Dr. Whitmore's criticism? Well, he ignored it. And he continues to invoke Berthold's mechanism, even though it doesn't apply to the Castile and Green River laminae. So we look at the Castile Formation, we don't see any evidence of sorting that would be involved with the Berthold sorting mechanism. There's no evidence of graded bedding, no evidence of cross-bedding, ripple marks, or other sorting features. The anhydrite and calcite are moderately water-soluble and very soft minerals, but yet they're often euhedral but macroscopic in the Castile Formation, which means that they're very crystalline. They have nice crystal faces on them that show no evidence of wear and tear from sorting. And so here are some euhedral calcite crystals. These have not been eroded. So a lot of young Earth creationists are now recognizing that sedimentary processes in Dr. Berthold's mechanism don't apply to the Castile Formation. And so they're looking for other solutions, namely igneous solutions and hydrothermal or hot water solutions. So we'll look at some of those hypotheses. And first of all, we need to look at some melting and decomposition points for salts. And unfortunately, I don't have high pressure data on this, which would apply to magmas and deep subsurface conditions, but this is at atmospheric pressure. At 800 degrees Celsius, calcite decomposes to lime, calcium oxide, and carbon dioxide. Halite melts at about the same temperature, and then anhydrite melts at 1460 degrees centigrade. That's pretty hot. That's a temperature of mafic lavas and plutons. In other words, it's the temperatures that basalts and gabbros would form at. rather than granites form and rhyolites form at much lower temperatures. So here we deal with the young Earth creationists saying that volcanism formed the Castile Formation. They would argue that it was either lava flows or ash falling into the water. But then we'd have to ask, how can millimeters to centimeter thick lava flows of organic matter, calcite, and anhydrite remain molten over 113 kilometers even on dry land? It's not going to happen. How could ash falls produce 418,000 chemically distinct and thin and uniform layers through a stormy atmosphere and turbulent waters of the Genesis flood? Well, it can't. If the volcanoes were, let's say, outside of the Delaware Basin, why is it that the Castile Formation is restricted to the Delaware Basin? With 100 years of drilling for petroleum in the region, why isn't the formation also found in the nearby Permian Basin? Okay, how did the organic matter form in igneous rocks if it wasn't from algae and phytoplankton? Okay, the stable carbon, sulfur, and oxygen isotope analyses support a marine sedimentary origin for the laminae and not volcanism. The thicknesses and the halite layers in the Castile Formation occur in 1800 to 3000 year cycles. Now, how could that happen during Noah's flood? And so what kept the molten anhydrite from degassing the adjacent calcite layers and causing gas bursts? So here we have, let's say, a layer of molten anhydrite. If it comes in contact with this calcite layer, the calcite layer is going to explode and release carbon dioxide gas, and it's going to be shattered. So they're incompatible. So other creationists or young Earth creationists, are arguing that it must have been magmas. In other words, these molten salts formed deep within the Earth. But this doesn't really work either. First of all, there's no evidence of diapirs. Now, young Earth creationists, or at least some of them, think that diapirs are plutons. In other words, this was molten salt. It's actually not. Salt can flow in a solid form because of density differences. The salt has a far lower density than the overlying silicate-rich rocks. And so you get the salt flowing upwards. And of course, we see this all over in the Gulf of Mexico, and they have petroleum associated with them. So there's a lot of petroleum exploration. And we can actually see the diapirs not only from drilling, but also from geophysical studies. Now, there's no evidence of stocks or feeder dikes in the Castile Formation. There's actually detrital sedimentary quartz, zircons, and other grains are present, which means that the Castile salts formed on the Earth's surface and not deep within the Earth. Also, oil forms in a very narrow temperature window below 200 degrees Celsius. So if you had molten salts, the oil would break down into methane gas, and you wouldn't have any oil in the Delaware Basin that we've been using for the past 100 years. So how could the magmas also reproduce the 1800 to 3000 year and other cycles that we see in the Castile Formation? There's also no evidence of contact metamorphisms. You get to anhydrite at 1460 degrees Celsius and higher. If it comes in contact with another rock, it's going to bake it. Also, the molten anhydrite would again decarbonize and destroy associated calcite layers. And once more, the stable carbon, sulfur, and oxygen isotope analyses support a marine sedimentary origin for the Castile Formation. So also the igneous and hydrothermal salts tend to be enriched in trace elements such as rare earths, lithium, boron, and beryllium. The trace element chemistry of the Castile salts is consistent with the seawater origin. Now, Wilhelm Bloom is going to have an article in the next issue of the Journal of Creation, either November 2021 or March 2022, where he argues that an igneous origin for salt deposits doesn't work. So even creationists are beginning to recognize this. So Snelling, another young Earth creationist, argues that the supersaturated brines formed from igneous or hydrothermal origins. In other words, we were dealing with a hot brine instead of a cold one, like what Ord thought about. But how would this work? Again, you still don't have enough time to precipitate 418,000 uniform salt layers. You would have to have a lot of heat, to produce calcite and gypsum saturated brine in seconds. The rocks would melt and the calcite would decarbonate. You would also have to have seawater or other aqueous solutions would have to come in and recharge the brines to produce the next set of calcite and gypsum layers. And again, the hydrothermal model can't explain the 1800 to 3000 year cycle. Okay. The mineralogy of the Castile Formation is very simple without magnesium or potassium salts like what is found in the Mediterranean and Red Seas. Hydrothermal models may explain the massive subsurface salt deposits with unusual magnesium and potassium salts in the Mediterranean and Red Seas. However, the chief proponent of the hydrothermal model, Dr. Hovland, admitted to me that his model may not apply to the Castile Formation, and I don't think it does. So here's the chief young Earth creationist model for hydrothermal and volcanic deposits. It was developed by Nutting in 1984 and modified by Williams in 1989. Now, it requires some very stagnant or stratified brines. You need to have a brine at the bottom that could allow halite to precipitate every once in a while. But how could this form? Because despite meteorite impacts, earthquakes, turbidity currents, volcanic eruptions, and the other chaos of Genesis flood that young Earth creationists typically commonly advocate, this model requires brine stratification. And there's no volcanic or hydrothermal vents found anywhere in the Castile Formation. And you can see here that if you did have vents, that the layers would actually thin away from the vents or from the hydrothermal vents. But the layers are very consistent over, again, at least 113 kilometers. And if you had multiple vents, you would have interfingering layers and they would still be inconsistent in thickness. So this just doesn't work. Also, carbonatites, which are volcanic calcite deposits, form with very alkaline silicate igneous rocks. Where are these silicate igneous rocks? What you have is a very alkaline magma that differentiates into a material that ends up forming carbonatites, and then a remaining alkaline silicate magma that solidifies into cyanites and other alkaline igneous rocks. We just don't see this in the Castile Formation. Okay, again, the layers are very uniform in thickness, and this is inconsistent with these vents in this model. There's also no igneous or metamorphic trace elements found in the salts. The trace element composition is, again, consistent with seawater. There's no unusual rare earth elements in the calcite, no purple or green anhydrite, no unusual boron, beryllium, lithium, or concentrations in the salt deposits either. And I'll try to show you some pretty hydrothermal anhydrite. Let's see, I'll bring this over.
We're all about the pretty stuff on this channel.
Yeah, we try to get some pretty pictures so I don't completely bore all of you. But
we've got almost 60 people watching, and people are really into the channel.
Well, okay, very good. This is okay. Here's purple anhydrite. See how beautiful that is?
Yeah, that's gorgeous.
Fantastic. Now here is some greenish blue anhydrite, also hydrothermal. Now I saw a green anhydrite at the University of North Dakota collection. It was bright green like grass.
Oh.
Now I don't know. I couldn't find out what trace elements cause these colors. It could be iron. Iron does not form a solid solution with anhydrite.
Right.
And so if you have a few parts per million of iron in here, it could end up producing a lot of pretty colors. And of course, with seawater, most elements aren't very soluble in seawater. And certainly chloride and sodium are. So you don't get the diversity of colors and that you would see in anhydrite, in marine anhydrite, that you would in the hydrothermal anhydrite. Okay. All right, so we'll proceed on.
Gorgeous. Those are so pretty.
They are indeed pretty. Let's see. And so we'll look at the uniformitarian or the scientific Kirkland model. And this model says that 255 million years ago, you had a very dry climate with a humid season and then a hot, dry summer. And so here again is what the geology looked like 55 million years ago. The salts from the evaporation of the seawater formed at or near the surface of the brine. Okay, the enclosed Delaware Basin needed a source of seawater. Now, surface channels would be unreliable over 100,000 years. There might have been a couple of channels here, or one here too, but they have a tendency to expand or close over time and not provide the necessary long-term volume of seawater for the Kirkland model to work. So, however, subsurface reef rubble is an ideal medium to provide seawater for the basin over hundreds of thousands of years. And so the reef rubble is permeable enough to allow seawater to enter the top of the basin and for a dense brine to exit out of the bottom of the basin. However, the rubble is not permeable enough to allow macroscopic organisms, either living or dead, to enter the basin. The presence of sulfide minerals and some of the calcite layers and the abundant organic matter indicates that you have low oxygen bottom conditions in the sea. Unlike the underlying Salado or overlying Salado Formation, the Castile Formation has no evidence of shallow water features. That is, the brine never got close to entirely evaporating. And so here's the Kirkland model. We start out with the late humid season. The groundwater is flowing in as usual. And here evaporation is low because there's lots of cloudy conditions, maybe not so much precipitation. And not much brine, heavy brine to flow out of the basin. But you get algae forming on the surface of the sea, and the growth of algae and other phytoplankton cause calcite to precipitate. Now, as the climate or the season warmed up somewhat, you would start to get evaporation, and then additional precipitation of calcite would occur. Okay, then by the late hot dry season, the brine would fall. You would get extensive evaporation, and the brine level would fall by about 2 to 4 meters. And at this point, evaporation is greater, and evaporation and the brine reflux is greater than the amount of marine groundwater coming in. So eventually, during the dry season, extensive evaporation causes the gypsum to precipitate. Now, in very dry years, every 1,800 to 3,000 years, halite precipitation can occur. The halite precipitation could last from less than 50 years up to several centuries. So this is the cycle I was talking about. It's a climatic cycle that the young Earth creationist models can't understand. It cannot occur, or they can't explain it during a year-long flood. Okay, so again, you have sodium-rich bottom brines above 18 degrees Celsius. The gypsum may dehydrate to anhydrite. Otherwise, the gypsum is going to dehydrate to anhydrite after its burial. Now, the gypsum precipitating brine cannot retain carbon dioxide from the atmosphere, which hinders the growth of phytoplankton and causes the gypsum to be free of organic matter. And that's why you see here the calcite has covered with organic matter, but the gypsum is not. It's free of organic matter. And again, the igneous and hydrothermal models cannot explain why the calcite has the organic matter, but the anhydrite gypsum does not. Okay, then we get into the late dry and early humid season. Things are beginning to cloud up, and the seawater is able to catch up with evaporation and refill the basin. And then by the late humid season, the cycle restarts. So this is how the calcite and anhydrite varves form in the Castile Formation. This is a uniformitarian model. And this model was specifically developed for the Castile Formation. The trace element chemistry is consistent with the evaporation of seawater and not igneous or hydrothermal origins. Again, with the stable isotope chemistry is consistent with seawater. The strontium chemistry is consistent with seawater, and the strontium's chemistry indicates that no more than 15% meteoric groundwater was involved in the precipitation. In other words, precipitation from the atmosphere accounted for no more than 15% of the precipitation. The other 85% was from seawater. Okay, so Ord doesn't like this model. And first of all, he quotes Anderson, 1972. And he says that Anderson admits that the laminae in the Castile Formation could never have been conclusively demonstrated to be Varves. Now, Ord often quotes old uniformitarian literature to promote his agenda, and he ignores more recent literature. And but if you look at what Kirkland said in 2003, he concludes the following about any model that attempts to explain the laminae of the Castile Formation. Any hypothesis calling for a period less than or more than 1 year would be extremely or exceedingly difficult to support. And most of all, Anderson, since 1972, now fully supports the presence of Varves in the Castile Formation and says that the formation represents 209,000 years of deposition. Okay, so Ord doesn't mention these things. Now, Ord also misquotes Kirkland et al. 2000. Ord says, first, it is difficult to verify that the Castile Formation rhythmites are Varves, and he quotes Kirkland et al. So I went through the Kirkland et al. Article looking for something that might be difficult to explain. This is the only sentence I found. The Castile Varves cycle is difficult to verify. In other words, Kirkland et al. Were talking about the Varves cycle and not the Varves themselves being difficult to identify. And then Kirkland goes on in the very next paragraph to contradict Ord and state that the Varves model is well supported by geochemical evidence, similar Varves deposition in modern salinas, the great regularity of the layers, and the thickness of the salts is consistent with a reasonable evaporation rate. Okay, so again, Ord complains that we don't see these kind of salt deposits forming in modern environments. And again, modern uniformitarianism does not demand that every depositional environment in the geologic record have a modern analog. The lack of modern analogs is simply due to the current lack of large and isolated marine basins in arid climates, which mostly occur around 30 degrees north and 30 degrees south latitude. The closest modern analog to the Castile Formation is the Dead Sea, which also precipitates calcite, gypsum, and halite, but on a much smaller scale. The existence of ancient, large salt deposits is adequately demonstrated through field, lab, and computer analyses. Okay, so now Ord complains that it would take an unrealistically large amount of seawater to produce the Castile Formation. He estimates that it would take about 9.17 million cubic kilometers of seawater would have to evaporate to produce the Castile Formation, and he thinks this is unrealistic. Well, okay, so how much would that be in a year? That would be about 52 cubic kilometers of seawater per year. Now, in comparison, the Amazon River discharges 5,500 cubic kilometers of water per year. So if the Amazon River can discharge that much water in a year, why couldn't 1% of that volume of seawater have annually leaked into the Delaware Basin? And I think it could. Now, an evaporation rate of about 4 meters per year would be needed to explain the average thickness of the anhydrite layers in the Castile Formation. This is reasonable. The current rate of evaporation in the Red Sea is about 2 meters per year. Dead Sea is about 3 meters per year. But however, there are other modern evaporative sites with rates up to 5.9 meters per year. Okay, then Ord says, well, if the seasonal overturning of the brine occurred every year, what kept the delicate salt laminae from being destroyed? Now here, Ord accuses Kirkland, 2003, of contradicting himself by stating that brine stratification was persistent over time, but then, on the other hand, later discussing how wind-induced overturning destroys the stratification and equalizes the brine density. Once more, Ord fails to understand what Kirkland is saying. Contrary to Ord's misunderstanding, overturning did not occur every year. Okay, the overturning only occurred for about 50 to several hundred consecutive years, once every 1,800 to 3,000 years, when the climate became exceptionally dry. Now, during those very hot years, the salinity of the surface brine became very high, and its density matched the bottom brine. And then the surface winds would then allow the brines to overturn or mix from top to bottom. Now, I should point out that Ord cites Kirkland, page 109, but he misses this statement on the same page where it says, similarly, the Castile brine mass was probably persistently stratified with only infrequent periods of seasonal overturn. So again, Mr. Ord is not carefully reading the literature. Okay, next he asks, how could the reef rubble remain uncemented and highly permeable for hundreds of thousands of years. Now, in general, reef rubble is usually pretty permeable. And permeability is the ability of a rock to transmit a liquid. Porosity is the percentage of openings in the rock. And so Kirkland estimated that the porosity of the Delaware reef rubble was greater than 20%, with local openings of 10 to 50 centimeters. And then the permeability would have been quite high. Obviously, these openings would not extend completely through the reef rubble, but it would be patchy. But still, there would be enough porosity and permeability for seawater to move through the reef rubble. Now, these, again, openings are too large to cement, especially if the seawater is constantly flowing through them, but the openings, since they were not continuous enough, would not allow for the migration of macroscopic marine organisms. Okay, so next, Ord complains that there's no pathway to remove the brine from the basin. Now, except for 50 to a few centuries, every again, 1800 to 3000 years, the brines were stratified. Now, the bottom sodium chloride-rich brine would have exited out the bottom of the basin. Here we have the dense brine in dark blue exiting out the basin, and the seawater coming in through the top. And Ord is very skeptical that this mechanism will work, but yet it's currently seen in the Bosphorus Straits of Turkey. So in many places, we see water flowing in opposite directions, flowing one way, deep water, and in the other way, at the top of the water. Now, I should point out, again, that Snelling, Lunning, and others rely on stratification in their hydrothermal igneous model during a chaotic flood. So why couldn't young Earth creationists accept stratification in a tranquil basin? Okay. Next, Ord expects the halite to anhydrite ratio, the Castile Formation, to be 30 to 1 from seawater evaporation. Instead, it's about 1 to 1. So Ord wonders why the anhydrite is in excess in the Castile Formation. But he should really be asking why the halite is missing. Conditions in the Delaware Basin simply were not dry enough for evaporation to produce a lot of halite, again, except maybe once every 1800 to 3000 years. And also the halite is far more soluble in water than anhydrite. So the halite was more likely to be dissolved by groundwater after burial. And if it was dissolved, then the anhydrite would collapse and form a noticeable breccia. Now, to get a 1-to-1 ratio, Kirkland states that about 11% of the seawater entering the basin would have to be expelled from the basin as a dense brine, and this seems very reasonable. Okay, next, Ord complains, where's the wind-blown silicate dust and the river sediment around the Castile Formation? Well, with the Delaware Basin, as it became more isolated, the silicate-rich silt that's found in the underlying Bell Creek Formation became absent in the Castile. Although there are some silicate red beds away from the depositional site, most of the dust probably would have been calcite, in other words, blowing in from these carbonates on the surface here, and indistinguishable from the calcite precipitates. Now, Anderson did find tiny quartz and zircon grains in the Castile Formations, and they're likely windblown. Also, the area was too dry for permanent and abundant streams. Now, the area did have monsoonal climates, 255 million years ago, but monsoonal climates are not necessarily very wet. It's basically just primarily cloudy and cooler, and Arizona has monsoons, and it's a desert. We have to ask the young Earth creationists also, where are the silicate sediments from the Genesis flood? Why were they kept out of the Delaware Basin? And so they need to explain that. Actually, the young Earth creationists argue that Noah's flood brought sediment from the Appalachians all the way west to Texas. Well, that's the case. Why did it miss the Delaware Basin? It turns out that if you look at mountains, for example, the Andes, the Amazon River sends sediment from the Andes mountains out into the Atlantic over 1,000 kilometers. So it's likely that way back in the Paleozoic that you had sediment washing out of the Appalachians and then going to thousands of kilometers out towards the west. So you don't need Noah's Ark to explain that. Okay, so Ord refers to the Kirkland model with its 200,000 year plus long stable environment for precipitating salt varves as extremely far-fetched. But yet the Kirkland model is completely compatible with the laws of chemistry and physics. 200,000 years is very brief in geologic time. A 200,000 year model is completely compatible with stable tectonics and the paleo environments of the area at that time. The model is totally compatible with the geology of the Castile and surrounding formations. On the other hand, as we see in the young Earth creationists, have a tendency to make up claims about anything. They have a lot of arm-waving speculation and very little evidence. They need to come up with chemical and physical evidence and solid models for the Castile Formation that they don't currently have. And most of all, secularists would argue there's no evidence of a talking snake and magic fruit trees, and that Genesis 3 is the actual extremely far-fetched story. So in conclusion, currently, the young Earth creationists, sedimentary, igneous, and hydrothermal proposals totally fail to explain the hundreds of thousands of laminae in the Castile Formation. The Castile Formation is totally incompatible with flood geology and a 6,000 to 10,000 year old Earth. Young Earth creationists have a lot of elaborate speculations, but without invoking magic, their proposals don't work. On the other hand, the Kirkland model works just fine, and there are other uniformitarian models as well that also work, but again, they're not compatible with young Earth creationism. So without Genesis, there's really no reason for young Earth creationists to believe that the Castile Formation is only a few thousand years old. And Bible critics would argue that the best explanation of Genesis 1 through 11 is that they are made-up stories. They should be rationally dismissed as nothing more than myths. Now, the traditional strategy of critics of young Earth creationism, which would include old Earth creationists and theistic evolutionists and secularists, have been to refute young Earth creationist arguments. But for every argument we refute, young Earth creationists come up with 2 or 3 more. Now, the secularists are using a different strategy now. The secularists recognize that if the public rejects the Bible as a whole, or at least young Earth creationist interpretations of the Bible, then young Earth creationism and flood geology is doomed. And so they're attacking the Bible. And here we have some interesting books. Dr. Robert M. Price has 2 Ph.D s in the Bible. He is an atheist, and he is a mythicist. He believes that Jesus probably never lived, and he also argues that all or almost all of the New Testament is a 2nd century forgery. That's pretty radical. It's also interesting that he is a Trump Republican. So people should not accuse all atheists of being hardcore leftists and libertarians. Now, Finkelstein and Silverman are archaeologists. They have found no evidence whatsoever for the Exodus from Egypt, and they've actually, through their archaeological work, have identified that the ancient Israelites are Canaanites that migrated from the upper lands of Canaan down into the lower lands, not from Egypt. John Loftus is a former student of evangelist William Lane Craig, and he is an atheist. Now, the more moderate of the group is agnostic Bart Ehrman. I'm also an agnostic. He actually believes that Jesus lived, and he actually believes that Paul wrote 7 of the letters out of the New Testament. So he's more moderate. Ken Hand recognizes this new secular strategy, and I think it has him worried. Here, in his cartoon, he has the young Earth creationists and the fundamentalists shooting each other in the foot, and then aiming for the positions, the various political positions that the secular humanists have, well, maybe except for Bob Price. And on the other hand, the secular humanists are blasting the Bible and are having some success with it. And so anyway, I will now conclude my talk. If there are some questions here, I hope that, let's see here, I'll stop sharing that. I hope you weren't too bored with it.
Oh my gosh, no, that was superb. The chat was completely pumping the entire time. That was a very, very educational for me. I think the Castile Formation is going to be my new go-to for just one single geologic formation that it precludes young Earth creationism entirely, which, as you presented, it absolutely does. We have some questions if you would be willing to take them.
Yeah, I should also mention that the references that I used in this presentation are on my website and also in Reinforth's book. And certainly if people want a list of references, I can send them to them that I used in this talk. I should have probably shown the references. Yeah, no problems with questions here. So we'll go ahead and I'll try to answer them.
Yeah, sweet. Okay, the first question that we have is from Gerard Trigo, and they wanted to ask you whether or not formations like the Persian, or seas, I suppose you would say, water, marine formations like the Persian Gulf, Caspian Sea, Dead Sea, and Great Salt Lake, whether or not those are considered to be modern saline basins.
Well, the Aral Sea is. That's because under the Soviet Union, they diverted the river water for irrigation. It's dried up. Offhand, I don't know the salinity of the Caspian Sea. The Black Sea technically isn't. It has the Bosphorus Strait is open. And so the Dead Sea is, again, probably the closest analog to a to the environment that produced the Castile Formation.
Okay.
We just don't have a lot of large basins in the 30-degree north or 30-degree south latitude at this time due to plate tectonics.
Right. Yeah, absolutely. That kind of plays a little bit into Origami Swami's question, who wanted to ask, and I think you touched a little bit on this a few times during the presentation, well, whether or not there are similar locations in the world today where this process is still happening. And as you noted, the Aral Sea and the Dead Sea are kind of somewhat analogous, although perhaps not as extreme.
Excuse me?
I was more asking if the Aral Sea and the Dead Sea were kind of analogous to the Castile Formation, but not quite as extreme.
Yeah, well, they're actually more extreme with the Aral. I mean, again, there's no evidence that the Castile Formation formed from a brine completely drying up.
Right, right.
But the Dead Sea is, yeah, pretty close, but on a smaller scale. You get the same minerals, anhydrite, or excuse me, gypsum, calcite, and halite. Yeah.
Okay. Dessel Drace wanted to know if perhaps olivine could have been the mineral that produced the green anhydrite.
Olivine?
Yeah, olivine. Sorry, my mistake.
No, that's a mineral. No, the anhydrite is calcium sulfate, and olivine is a magnesium iron silicate. So they're different minerals.
Okay.
You can use X-ray diffraction and verify that it's an anhydrite, and then technically you could dissolve it and do a detailed chemical analysis to find out what's in it that might be causing the trace elements. But they're both the olivine and the anhydrite are orthorhombic minerals, but the chemistry is completely different.
Okay. All right. Cool. Jerry Farmer wanted to ask if there are any particular fossils that could be found in the Castile Formation.
Not that I know of. It just wasn't very hospitable to life. I mean, how would organisms get into it when it's enclosed?
Yeah.
It was the brine would have been very low in oxygen, and at that time there were no birds, no mammals, walking around to fall into it. So
right. Yeah, the Permian too. Yeah, that's, I mean, wishful thinking for a synapsid, but I don't know. Mr. Wilford wanted to note to you that they've talked to Kirkland themselves, and that he says the fact that the depression rate of calcite was so high, then for any given var, far off silicates blown in would be a very low concentration, which is precisely what we see. So completely backing you up there.
yeah, that's very likely.
Yeah, and then let me check real quick to make sure that we don't have anything too new going on here in our chat. A lot of people are loving it. They're saying they're going to have to go through it much slower at another juncture to kind of maybe take notes and soak it all in. I have my essay at my Talk Origins website. They go through the references that are there that
please check my references, make sure I'm properly quoting everything, and you can take your time and read it.
Yeah.
And
Yeah.
that's another thing too, is that some people have come to me and asked me if I'd be willing to do debates. Maybe written debates. I was in an email exchange that lasted for 10 years. I would prefer not to do that again. But if somebody has a critique of what I've said tonight or on my website, they're welcome to write something up and send me a link, and then I'll write a response and send a link back to them, and we can go back and forth. On oral debates, I saw how Ken Ham treated Bill Nye and what Bill Nye said. Ken Ham made a lot of money selling books and videos, tearing up what Bill Nye said and talking in more detail. I don't like that possibility. I have at least two conditions for an oral debate. First of all, I would want to be compensated a lot of money, because I would probably be used in propaganda films for the unearthed creationists. I don't like that. And then secondly, any debate that I participate in would have to be centered on the Bible. Now, I would certainly defend uniformitarianism and geology and naturalism, but the debate would have to be on the Bible, and the opposition would have to give good scientific evidence that there was a talking snake and magic fruit trees 6,000 years ago. That's a requirement.
I suspect the takers for that are probably going to be quite low, which I think speaks.
Yeah, considering how much money I would probably charge for a debate, or an oral debate. Written debate is certainly, people can send me stuff and I can exchange. But I can't afford to be involved in 20 written debates with people over time, and so I may not be able to reply to everything. But I can, if I get a very reasonable refutation of what I've said tonight, I can write up a response defending myself on my website, and then let the individual know and so forth.
Yeah, absolutely. Yeah, I suspect you'll probably get some responses in video format, and if that is the case, please let me know if you feel that there's anything worth responding to in it. And I would be happy to plug your website responses, or if you want
that's another thing too, is I do not watch videos.
Yeah.
So if you're going to give a response tonight and you want me to see it, it's going to have to be in writing.
Yeah.
So that I can print it off. I don't want to go through long debates from opponents. And so anyway, that's another condition there.
I don't blame you one bit for that. I sincerely don't. I want to do a double check, make sure that's all the questions that we had. I mean, honestly, I really do think that you were just incredibly crystal clear on your points. I was trying to think of questions that I had, and the second I would have a question, the next slide would, would address it. So I think that was superb.
Thank you very much. I'm also willing to do a talk on the Green River Formation at your convenience, which is another formation. It's from the Eocene, about 50 million years old, dealing with Varves that, again, creationists just completely misrepresent. So I can do that sometime. I don't know, in the near future, we can arrange that.
Yeah, people have loved this. The chat has been great. We've had a very consistent audience.
Wow.
I think people have been very, very into it. And I would love to host you for a Green River talk as well, if you'd be willing. Yeah,
well, I'm really happy that people enjoyed it and weren't bored, and that's really great that people enjoyed it. I appreciate that greatly. I appreciate you, Erica, for inviting me.
The appreciation is all mine. This was I say I love to have the geology talks, because for me the geology talks are always where I feel like I learn the most, because I have to pay attention to the littlest terms, and it kind of has me on my best behavior during the entire lecture. So
yeah.
Well, guys, thank you so much for being here. This was an absolute ball. And Dr. Henke, Kevin, if there's anything else you want to say before we go, then we'll end it after that.
Well, I thank you again very much. I thank you all for watching, and I'm sorry that things kind of started out slow because of mechanical difficulties. Hopefully, if we do a talk on the Green River Formation, that those problems will be worked out. Now, Erica and I did test the equipment beforehand, but again, to put it live on the air is another thing, and that didn't always work out very well. But,
man, we did. We did a tech meetup about a month ago, and then we also arrived early and did another one here. So sometimes.
Yeah. Oh, it worked fine then, yeah, until you put it on the air.
Yeah, exactly.
So, yeah.
The tech gremlins sense fear, and then they're like, oh, okay, start pulling things apart. Okay, everyone, thanks once again for being here, and we are going to end the broadcast now. Please leave a like and subscribe and hit the bell if you feel like it. We always appreciate it, and thank you again.
Thank you. Goodbye.